last 3 years, we've been able to build a product that there's nothing else like it in the industry worldwide.
You guys are the key to our entire project right now. This is the first time where we have more contracts than we could possibly even put out machines.
In our space, we get to be definitively different. You can't compare us to our competitors, and that would not be possible without this program.
Every one of the technical challenges that we had, TSL was able to overcome.
No one wants to be living in data files and Excel files all day long, so now our team gets to focus on the really strategic initiatives that they're very, very good at.
Instead of going there, flying up there, doing a service ticket, like connecting, reprogramming, now all of this you can do from your fingertips, sitting right here from an iPad.
Some of those processes before, when your team had already some level of automation, took them still 90 minutes. That's now done in minutes, seconds.
Working with TSL has been nothing less than stellar. They're great communicators, do a great job, make suggestions, deliver.
Really do appreciate the time and effort and commitment commitment that the devs have made.
It's great to work with people who have the same values and beliefs and ambitions.
Anytime somebody wants to choose a supplier, they should look at reputation, they should look at integrity, and they should look at quality. And TSL has proven to me that you achieve those three attributes.
Having a team that could be there for the longevity is really key.
They really knew and understood our business and asked a lot of questions to get to the root of what we were trying to solve. It actually came out better than we thought because of those questions that they asked.
An excellent experience.
It's been just insane.
It honestly exceeded our expectations in every way.
Quick icebreaker, because we want this to be an interactive one. We don't like to just monologue at you guys for about 45 minutes. So, AI New Year's resolutions. Who got some? Ooh, we got a shy crowd.
Don't spend all day prompting. Yeah.
Don't spend all day prompting. I like it. Does that mean get better at prompting?
Yeah,
Or
exactly.
don't go down the AI rabbit hole of like, ooh, what if I ask it this?
Time limits.
Time limits.
Yeah.
And any fun new systems that over the holidays, you know, when you guys had to take that really important meeting but really just needed a break from family, any AI systems that you guys played around with or tried out new ones?
Whisperflow.
Whisperflow.
Yeah.
What does Whisperflow do?
Whisperflow is an audio. You can talk your prompts.
Okay.
And it captures it really neatly, really clean, inserts punctuation, really simple. Put it on my phone, put it on my computer, doing a lot more talking and a lot less typing, which means I'm moving a lot faster.
I love that.
Speed and efficiency.
Honestly, the ability to dictate my prompt is one of the single reasons that I'm like latched onto ChatGPT and will not yet leave it. Although Google Gemini's dictation has gotten oh my gosh.
Much better.
Who saw the Gemini Dark Horse in 2025? Holy cow! It started the year and you were like, I'm not. They were like the person sitting in the corner, kind of rocking back and forth. You're like, I'm not talking to that model. By the end of the year, the thing was rocking and rolling. Well, we're going to continue the conversation about LLMs, but we're going to talk about a lot more today. Let me give you, quick poll. Who is first-time attendee at AI Uncorked tonight?
Oh, that's nice.
Welcome, guys. Welcome. Then I'll give the super tiny introduction. You guys, I'm Mark, and the company I have the pleasure of representing tonight is the Silver Logic. You can look around the room and kind of see some of the projects that we're involved in. For the last 13 years, we've been building custom software for startups, enterprises, all of which have been very focused on business process automation. And that means we've been doing AI since before LLMs, made it really, really cool. And for the last 2.5 years, we've hosted AI Uncorked every single month. So you guys come back. It's the third Wednesday of every single month. And this year, one of the big requests we got was not only to stay service level, but do a few sessions that dove deeper into some of the technical sides and got behind the scenes, maybe explored options beyond the LLM space. So we wanted to bring you that right off the rip this year. Ariel Gonzalez is our lead fractional AI engineer here at the Silver Logic. He's had a wealth of experience, and one of the things that he's going to be using as a focal point for his presentation tonight is a research topic he did and presented at IEEE at the end of last year. So, without further ado, everybody, welcome Ariel Gonzalez, and I'll let you take it away.
Thank you, Mark. Hello, everyone. I'm very happy to be here and very honored that they chose me to start off the first year's AIU. And I want to get to know you. Anyone here works in the HR space? Perfect, perfect. I got news for you. You're gonna learn a pragmatic way in which you're gonna approach your problems within HR. And for the rest of you, don't worry. The framework that we're gonna see applies to other domains outside of HR. So how are we gonna get there? Well, this is the agenda for today, and I'll give you a couple seconds to read the titles. And I know what, if you read it, you might think, Ariel, this don't make any sense. What do you mean by Tesla trap under the hood? You'll got to trust me on this one. So, what's the problem? Anyone here is a company owner? You can raise your hand. Perfect. Have you lost a key employee since the last year? At least one? You can raise your hand. You know, I can ask that question and be confident that at least one hand is going to be up. And it's not because I think it's going to happen. It's based on numbers. It is projected for this year alone that turnover is going to cost from 1.3 to 5.1 trillion US dollars. And you might think, Ariel, that number sounds a little bit far-fetched. $5.1 trillion. For a while now, we've known the cost of turnover. According to Gallup and the Society for Human Resource and Management, turnover costs per employee 50% to 200% of its annual salary. So if you do the math, it checks out. And that's just one of the HR problems. It is retention. But within the HR space, we have other problems that are equally important. We have hiring, we have screening, performance, workforce planning. But I want to focus on retention, and it is because it is a personal problem for me. I found out that retention is not just business cost. It's something that we should treat proactively. So I dedicated most of past year to some research about it and test AI strategies to try to solve for that problem. And the next question would be, how do we tackle then talent retention? That makes me think about a few years ago when Teslas were the hottest new thing. When you ask the question, which car should I buy? At that time, everyone said, hey, buy a Tesla. That's a revolutionary car. It's modern. It's electric. And thing is, some people took that advice to heart without giving it much thought and started buying Teslas in regions where there were no charging stations in miles and miles. So it is a cool car, it is revolutionary until you're stranded. So the same thing is happening nowadays with LLMs. Companies are adopting LLMs to solve problems without thinking if it is a right fit. And how did we know that Tesla wasn't a right fit for this situation? It's because we at least understand the generals about electric cars and how they function. So these are today's Teslas. And the way in which we're going to determine if they're a good fit for our problems is looking under the hood. This is what's under the hood. This is the general architecture for large language models. And it all starts at the first phase, tokenization. For every input that passes through an LLM, it's not just thrown at it. It is divided into something that's called tokens. In this case, the partial sentence, the cat sat, it is divided into single words, and those are called tokens. And once we have it divided into that unit that the LLM can start to comprehend, it goes through a layer that's called embedding. What embedding does is that LLMs don't understand text. As you can tell also by computers, they understand numbers. So we convert those tokens into numerical representations that are called embeddings. And nowadays, LLMs, for every word, they can create vectors of 1,000 to 2,000 numbers per word. Those are huge vectors. But let's try to abstract that, and let's think that we can represent each word with two numbers. If that's the case, we can plot that. And let's say that this is the vector for the word cat. Here's where LLMs start to be intelligent. For similar words, it generates similar vectors, similar embeddings. So a word like cat and kitten would sit pretty close together, but maybe a word like dog would be further away. And that's how it starts to make the connections on words and start to resemble some meaning or understanding. So after we do that, and we get all of the embeddings, it goes through something that's called positional encoding. And that means we need to have the information about the position of every token, because it is not the same to say the cat sat compared to sat the cat. So it needs that information. Once we have that, we go into the magic box of all of the LLMs, and that's the transformer layer. It first goes through an attention layer. And then attention layer, what it does is that it takes every token of the input and compares it to every other token. And that's how, if we have the sentence, the cat sat on the mat and it made a mess, it knows that it represents the cat. It's referring to the cat. Once we have all of that information, it goes through a feed-forward neural network that produces raw outputs, raw numbers, raw scores. And then that's converted into a probability distribution for every word in the vocabulary. So every word has a chance to be the answer. Let's use an example. Let's say that the input is the employee is likely to. And this is the probability distribution that the LLM produced. What do you think is going to be the choice for the LLM, seeing that those probabilities?
They're leaving.
Right. Higher probability, he should choose that as the correct answer, right?
Leaving, resigning, and quitting are all kind of the same thing, and that combine them is a lot higher probability than staying and remaining.
Exactly. But the thing is, LLMs don't use that logic to choose answers. It is like a lottery spinning wheel. Every word in that distribution has a chance to be selected, and that's by design. Because if it only selected the highest probability, the text would be bland. So we need some variety to produce text that resembles human text. So every time he's about to choose an option, it spins the wheel. So if we try to solve talent retention, for example, using an LLM and knowing that spinning wheel logic, let's say that we want to generate risk scores for a specific employee. And we throw that to an LLM. I made the example using a real LLM, using Claude AI, and I had these characteristics of a fictional employee and the same prompt, only some words changed. I asked him to generate a risk score for this fictional employee 3 times. And the 3 times, it gave a different score, 70 to 75, 72, 68. So do we really want to make decisions with the answers of an LLM if they vary that much? And then that's not the biggest issue. When an LLM says 70%, it is not based on your data. It is not because it analyzes your workforce. It is just pattern recognition. It is theater. So that 70% doesn't really mean anything against maybe a system that's calibrated and that's modeling your workforce or your data. So, getting to this point, I have a confession to make. I lied. I lied to all of you. I don't think you shouldn't start your strategy, your AI strategy, with ChatGPT. I think you shouldn't start with any LLM. With any LLM. And where do we go from here if I shouldn't start with ChatGPT, called Gemini? Well, LLMs are just one corner of AI. This is a map of all of the categories and subcategories of LLMs. And I want to ask you, where do you think LLMs land within these circles?
Machine learning.
Close. Any other guesses? Well, it is the innermost circle. We have first artificial intelligence as the general field that's broad, a lot of tools. Then we have machine learning with supervised, unsupervised learning methods, reinforcement learning. We then have deep learning as another subfield. And inside of deep learning, we have LLMs. So when I was trying to tackle the talent retention problem and try to figure out a strategy using AI, my first step was going up in the circle. Let me look for a solution for an algorithm that's simple, that's proven, and then we can start to make it more complex if needed. So, what entitles the, what's the thing with talent retention? What's the problem there? We have a lot of employees leaving maybe, and we want to act proactively. If I hear the word proactive, I'm hearing also prediction. I would like to predict who's the next employee that's going to leave my organization. And once I hear that, this is the two biggest fields in machine learning, on supervised learning and unsupervised learning. Supervised learning methods are for predictions, for classifications. And how they work is with labeled data. What that means is that my data knows the outcome. I know the employees that left. I know the employees that stayed. That's called labeled data. Unsupervised learning, that's for data that has little to no structure, and I just want to recognize patterns, maybe for anomaly detection. But in this case, the right fit is to dive into supervised learning approaches. So, knowing that, I started to dig into the possible algorithms that I could choose to solve the problem. And I went for an algorithm that's called random forest. How does random forest work? Have you heard the term decision tree? Perfect. It is the unit of a random forest. It all starts here. Here we have a simple decision tree. It builds this, and let's imagine that an employee is going through this decision tree, and it's asking, all right, is your tenure longer than 12 months? Okay, yes. Months since last raise, is it more than 18 months? Yes. All right, more than 18 months without a raise, tenure longer than 12 months. He then categorizes this employee as a high risk. So what random forest does is that it builds a lot of trees randomly, selecting different questions, and creates sets of employees at random also. And they all vote. And let's say we have 100 trees. If 70 trees vote that this employee is at high risk, then he has a 70% risk of leaving. That's the score, 70%. And the key insight and a big difference from this algorithm and all of the approaches in the supervised learning world is that the training, it is probabilistic. We are selecting batches of employees at random for the training set and for the test set. But once the training is done and we pass an employee to produce the assessment, the risk score, it is deterministic. There's no randomness at it. For the same employee, it's going to result in the same output. And this is some of the results I got from my research. I managed a real data set of a retail and trade organization with 5,000 employees. And the first thing that we figured out after building the model is that there are different risk bands that we assigned. And we categorize and place the active employees in each risk band depending on the risk score that the model produced. The employees at the second risk band between 500 and 1,000 in risk score had a 12.5% chance of leaving. But the next risk band, 1,000 to 1,500 risk score, jumped all the way to 89.9% on risk. What does that mean? That's an intervention point. The employees that live in that risk band, those are the ones that we're going to target for talent retention strategies. And we also found out that most of the turnovers occur in the first year. So this is the information that the HR department would get. It's not just text from an LLM. I think this employee is going to leave because, no, real numbers based on your data and a strategy that you can build and employees that you can target. And we obtained an accuracy, in this case it's called concordance index, And for those of you that don't speak statistics, that means if you grab every 2 pair of employee and you measure, let's say you have one employee that has a longer tenure than other, how many times is the model capable of giving a lower risk to the longer tenure employee? That's basically it. And it did it almost 9 out of 10 times. So, knowing all of that, I comprised all of that information into these 4 pillars. If you're trying to evaluate if an LLM is a good choice, a good fit for the problem you have at hand, first evaluate consistency. Consistency is, I'm passing the same input, am I getting the same output? LLMs are not capable of that. Calibration. It is modeling my data, is it? If not, not a good fit. Explainability. Can I go and dig into the model and know why it's making certain choices? For LLMs, there are black boxes. We cannot do that. For random forest, we have access to all of the trees. We can see the decisions. And auditability. And LLMs, unfortunately, you cannot audit them. So if any one of those falls, LLMs are not a good choice. And that brings me into a memory I have during my studies. I did a master's in AI. And we were learning about a very powerful algorithm called support vector machine. And during the final lecture, the professor told us, hey, I'm giving you a great algorithm. I'm giving you a bazooka. Use it wisely. And that stuck with me because it gave me a framework. For my problem, I didn't need the bazooka. I didn't even need a water gun for that matter. So the smart approach for any AI strategy, look for the simplest method that can solve effectively and efficiently your problem. I can bet you that if you're within the AI space, you're going to find a reliable method way earlier than testing with the LLMs. And at this point, I don't expect that here everybody's going to put their AI expert hats. That's not realistic. I'm not expecting that you go out there and learn about all of the algorithms. What I want you to have is the framework. Start to ask the right questions for you to become a satisfied buyer instead of only buying the Tesla for the sake of it. So this is the framework. These are the questions I think you should ask if you're evaluating a solution. If maybe you have an IT department, they're coming up with this great algorithm that's going to solve all of your problems. I want you to ask either the seller or your team, what was this model trained for? Was it trained to predict? Was it trained to classify? Or was it trained to generate text, images, videos? That's going to start to direct you into the right choice. Second, is the output calibrated? Are you taking my data and training your model to produce output? Or are you having a pre-trained model do the hard work? Last but not least, can I audit the system? Can I look and dig through it? And a lot of people overlook that last question. And back in 2021, there was a law, the NYC Local Law 144, and it was about that exact same thing. For employment decision tools that were automated, they wanted to make sure that companies stated that they were using AI and that they could audit the results. Nobody listened. Nobody listened, did their own thing. So back in December 5th, they said that they're going to enforce the law. So they're going to actively look for the companies that are not at compliance with that law. So it is not something to worry about in the future. That's something that we have to take into consideration nowadays, if we can audit our systems. So this is the last quote that I want you to take away. I don't think the people that's it's going to have success within AI initiatives go for the cutting edge solutions. What I do think is that they're going to have the right questions and that they're going to know how to buy the right car. So that's all we have today. Thank you.
I love it. Thank you so much, Ariel. Anybody with questions, throw those hands up. We've got our online audience, so even though the mic's not broadcasting, it is on. Trust me, it's not just a nice prompt. But I'll walk over to you, give you the mic so everybody online can hear the question, and then we'll let Ariel answer. All right. There we go.
So if you don't need a bazooka and you just have a traditional workflow and an application that probably can engage and solve the problem at hand, and let's say later on the data set grows where there's the interest to introduce some integration with a model, or how would you approach that?
Well, it is the same approach because it is harder to go with a complex model and then backtrack than starting simple and scaling. Now, I would say that. And maybe the complex model can solve your solution, but in between the testing, and especially with LLMs, there's a lot of guardrails that are going on. There's a lot of confirmation. So you're going to waste time. I would rather start with the simplest model that's solving my issue. And then when the necessity comes, I can scale. Less time that I spend testing solutions that are not the right fit at that time. I would approach it that way.
I think it was your second to the last graphic that you were showing kind of was indicating differences between LLMs and machine learning. And it seemed to be indicating that an LLM can't be calibrated. Maybe I interpreted that wrong, but one or two before that, actually. You had like an X and a check mark.
Oh, yeah.
Sorry, there we go. That's the one. Am I wrong for believing that an LM, you can still offer input data, like your own data, like a vector file, or a vector database of your own information that it can use, and that can essentially equate to calibration?
No, it's not the same term, because calibration, what it means is that it's taking your data to train the model. It can have access to the data to generate an answer, but it was not trained with your data. It's not going to happen. So it's trained, usually all of the LLMs are trained to generate content. You could calibrate an LLM, but you would have to write it yourself. All the commercial LLMs are pre-trained. So that's why I refer to calibration. It's the system using your data to train the model, not only to have access to it.
It seems like what you're describing is fine-tuning. Isn't calibration quantifying the confidence of the model?
No, because with LLMs, how are they trained? They grab all of the content in the internet, right? That's how they're trained. They have a bunch of text. Fine-tuning is something that you do to improve already done training. It's not something that goes beforehand. So you can take data to fine-tune it, but the base training, it's already done. So you're not changing the purpose of the system with fine-tuning. You're not changing the reason behind, for example, ChatGPT being a tool to generate text with fine-tuning.
But you're saying in your context of calibration that they would take data from the company and then train on the model.
That's calibration, basically. Modeling the data of your company or whatever.
I guess in my context, because my research is calibration of models and generative AI, for me, when I think of calibration, I think of quantifying the confidence of the model and making sure they're...
I can see, yeah. I can see the confusion. You can use that term for that specifically, but in this case, I'm using calibration to determine if the system, at its genesis, it's modeling your data. That's basically the definition of calibration here.
All right. We've got a couple questions from online. So first question was, why did you select random forest method against other methods?
Okay, I would dive a little bit deeper into that. The data set I was handling, it was pretty interesting. retail and trade, a lot of departments inside. And we noticed that the turnover rates per department were different. That means we were dealing with a heterogeneous data set, different patterns. So I needed an ensemble method that was able to handle heterogeneous data sets. So that's the reason why I went with random forest against other approaches. If the data had similar patterns across the departments, I wouldn't need to go with random forest.
Second one from our online audience is, do you think that LLM answers at some point will become deterministic?
I mean, there's one variable that's used within LLMs that's called temperature. Temperature is how much does it spin the wheel against only selecting the highest probability answer. So you can put the temperature to 0, and technically it is deterministic in the answer, but the whole process is probabilistic. So LLMs by design are always going to be probabilistic.
All right, we got another one from the online audience. If anybody here has a question, just throw your hands up so I can put you into queue. What dimensions related to the employee master data did the machine learning model use to determine whether the employee would stay?
Demographic data, performance. There were also, well, that was the main domains, demographic, age. If it had dependence, that's something that was used. The data I was using is coming from the Dominican Republic, and there we handle a lot of if this employee has children or any other financial responsibilities. That kind of data was handled. We didn't handle more data than that, because with only those two domains, there were more than 50 variables. It was enough for the model at that point.
On that same topic, could you talk a bit about feature engineering? Just in general, how people should understand that.
Well, I can talk from experience. And in my case, with this research, some of the features weren't able to be passed through directly to the model. And we also needed to craft different variables, compounding the ones that we had previously. So feature engineering, in a sense, is grabbing the raw data you have and figuring out which are the key parameters, key features that can improve the results of your model. So there are some methods that do this automatically without you digging into the data. For example, unsupervised learning approaches. But I would say you don't have to dig into the hard part, the math, to do the feature engineering. You can test your models with the set of variables that you have and see the performance. Sometimes even removing one or two variables improves the accuracy in predictions. That's something that can be done without much technical expertise.
With the system you built, how custom tailored was it for that specific client? Or for another one, would you just need their database and it can just work? Or would it require additional customization?
It was custom, pretty custom, but transferable to the same domain or the same type of companies, trade and sector, given the patterns behind it. But at the end of the day, you have to craft with the data that they have. Two companies won't have the same set of data sets, the same set of variables in their databases. So at the end of the day, it is custom built for that company.
All right, I'm going to stump your coworker real quick because I want to build off of a couple questions that we got. Kyle talked about, okay, we want to start simple, but is there, like, at what point do LLMs come into play? We just had a question about transferability. I think that one of the attractive things and one of the reasons LLMs have grown so quickly is they're productized, right? There are companies, everybody can go in, create a ChatGPT account, you can use AI. Awesome. There is an element of complexity, right, behind this approach. So how let's say we're a smaller business, right? We're a solopreneur, we've got a startup. how do we approach problem solving simply, through the lens of all the insight in your presentation, without having the productization that LLMs currently bring to the table?
Okay. You can still use LLMs. I want that message to stick. I'm not here telling you don't use LLMs. It's just I explain the use cases for them. So if you're a small company and you're deciding to go with another route and you don't have the expertise, it's like the example with Tesla. You go to the dealership. You go with experts because that's the reality. In this field, there are a lot of people selling snake oil, selling solutions that are the silver bullet. I can tell you, in AI, and in life in general, there's no silver bullet. So you can go for LLMs, and they're amazing at what they do. But if you need a solution and it is not the right fit, look for the right vendor.
All right, we've got a clarification question going back to the calibration point. Calibration, it's what some wearables do when you start using them. They have been trained with general data, and they start collecting your data to give you personalized insights. Is that a correct interpretation of calibration?
Yeah, it's one of the interpretations. It's
Okay.
right. Yeah.
Okay. Second question is, in a company, the machine learning model has to be run with the data every X amount of time. Does the model learn and improve the prediction?
Yes, it's part of the process. And it's done more often than not, because you still are gathering data. When time passes, more patterns, more employees, for example, in the case of turnover, come and go. So you're going to get better results by reiterating the training process.
When you build off of that question, when you reiterate the training process, is it important just to add a larger data set, or is the massive improvement given when you have results as well that it can correlate?
It can be both. It can be both. But I would say that this field in learning as a whole thrives from huge amount of data. And that was the strategy that exploited ChatGPT. It was not great architecture only. It was dumping massive amounts of data to get huge results. So I would say the biggest advantage that you can get is by taking advantage of a huge amount of data.
If I would attempt to build something like that with Cloud Code, what do you think are going to be the biggest challenges? And do you think it is feasible, or is it still far from that?
It is feasible. Don't get me wrong, it is feasible. But you're going to encounter a lot of back and forth, maybe more than you think, and handling the data. And also, I would say, knowing if the results are right and interpreting certain results. I would say that that's the hardest part, maybe not the code, getting the code. Nowadays, with all of these LLMs, you can get the code. Is knowing if the code is right.
In the deep forest algorithm example, one of the deterministic factors was the employee performance. If I remember correctly, it was like less than 3.0. So my question is, which formula did you use to calculate the employee performance?
It is something that was calculated by the company. That was data that was given, the actual performance scores. And the actual questions here to ask if it is larger than 3 or less than 3, this is an example. It's not based on the real data set. And it is made randomly by the algorithm. It chooses the features and chooses at which threshold is going to divide the tree. It's not something I do.
Okay, so that you have no visibility of how they come up with that coefficient for each employee.
I don't have the visibility of how the tree is built because it is random, but I can see the tree once it's built.
Okay.
Does this system have learning abilities? Like, as time changes, would it know how to determine differently than it does today?
You would have to retrain it. Mm-hmm. You would have to retrain it. That's the answer.
similar question, and building off of what Alex was talking about, which key employee attributes were the most influential in predicting employee retention within this model?
The biggest one was the type of contract. We found out that employees with fixed contract had a higher turnover rate compared to variable contracts. That was one of them, and the other one, well, yeah, it was the most important one of them all, the type of contract.
Variable contract meaning like commission? Or?
Commissions, yeah. It changed the ones that had a higher turnover rate. It was a 93% in difference between the ones that had a fixed contract against a variable contract. So, variable can mean a lot of things. It can be commissions. It can be hourly positions. It comprises all of that. Now, the fixed in the Dominican, we don't go by the hour system. It's just like a fixed salary. Yeah. Yeah.
Would the system be able to recalibrate? Let's say that after a year of implementing this, then the first decision, instead of tenure of 12 months, 10 months, or performance 2.5 instead of 3, or months since raise 15 months instead of 18.
Okay. It can be improved upon, but it's as the other question. You would have to retrain the model. It's something that's done automatically. If you stay with the same model and time passes, you're going to get the same quality of results as the first one, because it's not a model that's retrained automatically.
That will be the responsibility of the...
Exactly. Exactly.
Thank you.
All right, any other questions from our audience in here? Simeon, go for it.
Yeah. I believe at the end of your presentation you mentioned that staying ahead of the game in terms of LLMs is about choosing the right car. I would say what will be, I guess to be a poet myself, the road that we take might be bumpy in this case. So what bottleneck do you expect that LLMs might run into, and what would be the best way to overcome said bottlenecks?
I think the biggest bottleneck with LLMs, and you jumping in straight with them, is that sometimes we expect quality results all of the time. And as I explained before, that's not a realistic case. So you're going to be frustrated, like, hey, I spent all this money, and we brought this LLM into our systems, and from time to time, it's making mistakes. And it is bound to happen. So I think that's the biggest bottleneck, and then trying to figure out, all right, what's the right choice? And going back into the AI map and figuring out, all right, we'll go this route. I think that's the biggest bottleneck.
So it's iterative then?
Yeah.
Okay.
I know we mentioned, sometimes you got to go to the dealership and pick what's out there. Are there tool sets out there or that have the capabilities to approach problems a little bit more simply, but don't require us to fire up Claude Code, right, and build the system ourselves completely from the ground up?
Oh, well, I would say in terms of automation, we have tools like N8N. That's a great tool. It is simple to use. It is a drag and drop system in which you can automate workflows. So I would say that's one tool in which you don't need technical expertise. And you can start to, similar like LLMs that are now packaged as a service, you can go into N8N and other models like Make or Zapier and plug into LLMs or other solutions and have your workflows be automated. So I think that could be the route.
Okay, very cool, very cool. How would you approach, right? So N8N, AI workflow automation tool. How would you approach it with a more simple first, right, algorithmic or deterministic style versus just firing it up, plugging it into your favorite LLM, and then starting to ask questions or give it a vectorized data set?
Okay, sometimes we think that we need prediction and we need classification. And to be honest, I heard one time that during the last year, they wanted an AI solution for scheduling. And I was like, but scheduling is a problem that was solved rule-based with a basic computer system, an algorithm. You don't need complex AI to solve a scheduling. So I would say, first understand the problem you're trying to solve. And with any end, you can have rule-based there, code blocks, and solve certain issues. And you don't need to jump straight ahead into a more complex AI framework. So if you, in fact, need classification and need prediction, from my background, I would go with the technical route, because with any end, at the end of the day, you're going to plug into LLMs. You're going to plug into already built out solutions. I would go with the more build it yourself kind of way. Go with maybe a vendor. If you have an IT team that's capable of building the solution, start from there and then go down the route.
I love it. All right.
There's a question back here.
Yeah.
First of all, thank you very much. This is very insightful. I don't know if this question might have been asked already, but what's the right car?
That's the thing. It depends on the context. It depends where you live. It depends on your systems, your infrastructure, the problem you're trying to solve. There's no one single right car. That's the answer.
Great answer.
I have a question. I don't need a microphone. We had a previous speaker that was a physics PhD, and he had an interesting perspective where he said the next tipping point in advanced sciences that he sees is when AI can actually teach and learn and mentor and advance AI without using human intervention. That absolutely blew me away. Is that a real thing?
I would have to get more weight into the subject,
okay.
but from my understanding, we're talking about self-training,
Yes.
right? That the model is able to self-train itself.
Yes.
I would think about the physical constraints on that. We're now using a bunch of GPUs even to run these models. So think about those models retraining automatically. The amount of physical, electric power we would need for that to come along. So I would say, yes, maybe that's the next tipping point, but I think there are other issues we need to solve before that becomes a reality, like electricity.
Yeah. Thank you.
All right. Last call for questions here in the crew.
Actually, one more.
Yeah, absolutely. Tara's making sure I get my steps in.
I also don't know if this may have been asked, but are you just evaluating demographic data, or are there any potential other components, like potentially exploring values alignment within profiles to determine if that assists in attrition?
In this research, I didn't use data specifically. I used performance, the salary information, the schedule of the employee, but we didn't use that. That's something that we can explore further, maybe. Good insight.
Is there anything, like kind of on that note, is there anything that you could see that would do like behavioral patterns of the particular employee?
There's something that I was eager to explore but couldn't, and it's the behavior among the employees, the relationship among them. Maybe have the messages between them to try to, that could be interesting, right? But I know that with more data, it would be obviously better results, better predictions, but we're dealing with humans. So we have those strengths in how we do research with human data. So that's a blurred line. I would wish to go further and have more information. And the next step I want to do is to separate between voluntary and involuntary departures. That's something we can access that we didn't include in the research. I know that alone we will improve the results of this model. But I would say, yeah, there are some things we cannot do with human data.
All right, guys. Well, a warm round of applause for Ariel. Thank you so much for presenting. Like always, the conversation's over, but the party doesn't have to stop. We have restocked our wines and our cheeses and our hors d'oeuvres, so please get out there. Ariel is going to be out there mixing and mingling, so talk to him, discuss anything else that you want to bring up about this. He will be available for. And as I mentioned at the very beginning, I want to remind you guys, after I say a huge thank you for attending, that we run this thing every single month, and February's event is going to be a really cool spin on how to develop an AI-centric product. We are going to be hearing from Dennis, who is a Chief Technology Officer and Business Startup Advisor. He's going to be giving a presentation that's a sneak peek of his presentation for DataTrax, which is a massive conference up in the Atlanta area. So definitely pop in, third Wednesday of February. Dennis will be here. We look forward to seeing each and every one of you guys. And on behalf of the Silver Logic, Bridget, myself, Ariel, and the whole team, thank you for joining us.
Thank you.